GeopByte.
Similarly, let us take the another important problem. Okay, look at the screen. It is asking like this. A uniform force 3I plus J, which is a Newton, acts on a particle of mass 2 kg. It is given that force F equal to 3I, of course 3I caps plus J cap. Okay, and the mass of the particle given 2 kilograms. Hence, the particle is displaced from 2I cap plus K cap R1 equal to 2I cap plus K cap, which is in meters. Force is given in newtons. The position is given in terms of meter. To another position, I can mark that is R2 equal to 4I cap plus 3J cap minus K cap. Okay, it is also in meter. The work done by the force on the particle is, you are asked to decide work done by the force. For that, we need to decide the R. This R equal to net position, net change in position equal to R2 minus R1. Okay, look at the R2 value. This is the R2, 4I cap plus 3 J cap minus K cap minus R1, 2I cap plus K cap plus K cap. Simplify this part. It is 4 minus 2, 2I cap plus 3J cap minus 2K cap. That is the net change in position. Then work done equal to F dot R. Okay. Look at the F value. 3I cap plus J cap dot R value is 2I cap plus 3J cap minus 2K cap. Simplify this part. It is giving multiply I to I, J to J, K to K. I to I, 3 into 2, 6. 3 into 2, 6 plus J to J, 1 into 3 plus 0 into minus 2. Right? There is no force in terms of K cap. That's why it is 0. It is 6 plus 3. 6 plus 3 equal to 9 joules. That is the work done. Look at the option A. Option A is absolutely correct. Understood clearly? Yes. This kind of problem more frequently repeating. This is the fourth time or fifth time the similar problem we have been discussing. Therefore, I can say that this is the most important problem, five-star problem. Means this kind of problem has been frequently repeating. Okay. Similarly, let's take the another important problem. Look at this problem asking like this. The potential energy of a particle in a force field is, look at the potential energy equal to A by R square minus B by R, where A and B are positive constants. A and R is the distance of the particle from uh, constants, and this is maybe printing mistake, and R is the distance of the particle from the center of the field. For stable equilibrium, the distance of the particle is, it is asking for stable equilibrium. Dear friends, remember, for stable equilibrium, du by dr must be equal to 0. From that, I can write that d by dr a by r square minus b by r is equal to 0. Simplify it. Then it is minus a by, here it is a minute. Let me write it clearly. A Here it is A minus 2 r power minus 3, simple mathematics, minus V into minus 1 into r power minus 2 is equal to 0. Simple mathematics, school level mathematics, can be written as minus 2a by r cube plus b by r square is equal to 0, or 2a by r cube equal to b by r square, b by r square. R square part is cancelled. Then finally it is 2a by r equal to b. Therefore, the distance of the particle from the center of the field is 2a by b. That is the answer. 2a by b. Look at the option B. Option B is absolutely correct. Are you following clearly? Yes. Similarly, let us take the another important problem. Look at the problem asking like this. A car of mass m starts from rest and accelerates so that the instantaneous power delivered to the car has constant magnitude at p naught. That means instantaneous power of the car or instantaneous power delivered to the car is remaining same. That is given as p naught. The instantaneous velocity of the car is proportional to, you know, instantaneous power. Instantaneous power p naught is constant, is constant. But what is the power? Power P equal to force multiplied by velocity. P naught equal to F equal to what? F equal to ma. It is equal to m into dv by dt. In the place of m force, let us write the m into dv by dt into v. It can be also written as P naught dt is equal to m into v dv. Okay. Now let us integrate it. Upon integration, it means integral P naught dt is equal to integral mv dv. Here P naught is constant right outside. Integral dt is equal to m constant integral v dv. Here it is P naught t equal to m into v square by 2. V square by 2. From this I can write that v square equal to 2 p naught t by m. Here m is constant, p naught is constant, and 2 also constant. Therefore, I can say that v, right, v square is proportional to t, because p naught and m constant. V is velocity of the car or speed of the car is proportional to t power 1 by 2. T power 1 by 2. Look at the option B. Option B is absolutely correct. Understood clearly? Yes. Similarly, let us take the another important problem. Okay. Look at the screen. It is asking like this. The potential energy of a system increase if work is done. Look at the different options. By the system against a conservative force. Option B. By the system against a non-conservative force. Option C. Upon the system by a conservative force. Option D. Upon the system by a non-conservative force. Dear friends, remember, the potential energy of a system increases if work is done by the system against the conservative force. Therefore, option A is absolutely correct. Okay. This point already we clearly discussed while we were discussing the theory concepts. Do you remember? Yes. Then let us take the another important problem. It is asking like this. Which one of the following is present as an active ingredient in bleaching powder for bleaching action? Dear friends, remember the calcium hypochlorite. The calcium hypochlorite is the active ingredient in bleaching powder which releases the chlorine. Therefore, option A is absolutely correct. Remember that point. Right? Calcium hypochlorite is the active ingredient in bleaching powder which is releasing the chlorine. Therefore, option A is absolutely correct. Okay. Na? Similarly, look at the another important question. It is asking like this. Force F on a particle moving in a straight line varies with distance d as shown in figure. Look at the force versus distance graph given. The work done on the particle during the displacement of 12 meters is, you're asked to decide work done, right, for the displacement of 12 meters. The displacement is starting from the 3 meters and it is displaced to 12 meters. Then what is the work done equal to, you divide the, you know area in the force versus displacement curve is giving the work done. So this is the a1 and this is the another area a2. Work done equal to a1 plus a2 only. A1 is the rectangle area. Rectangle area equal to breadth multiplied with depth. It is 7 minus 3. 7 minus 3 into depth is 2 plus A2, that is triangle, half into base into height. Half into base is 12 minus 7, 12 minus 7 into height is 2. Now you simplify it. 7 minus 3, 4 into 2 plus half into this is 12 minus 7, 5 into 2. This 2 cancel. It is 8 plus 5. It is equal to 13 joules. That is the work done on the particle during its displacement from 3 meters to 12 meters. Okay, look at the option C. Option C is absolutely correct. Very simple problem. This kind of problem also frequently repeating. The fourth problem we have been discussing, the similar kind of problem. Remember, the area in the force versus displacement curve is giving the work done. For that only, you should know the rectangle area and triangle area, etc. Okay. Similarly, let us take the another important problem. Oh, completed. Right, all the problems what we prepared completed. I hope all of you clearly understood all the problems what we have discussed for work, power and energy. Understood or not? Yes. Thank you for watching. Okay. Yes.
GeopByte.